Hey, Jerry,
All right.
where's that bridge that's the picture that you showed?
This is in Cleveland, Ohio.
Yeah, I've been there. I'm just trying to,
This
I've
is
never,
on, it's called Lorraine and Carnegie. It's called the Lorraine Carnegie Bridge. There's two bridges. There's a Lorraine Carnegie and a Detroit Superior Bridge. I can't remember what that one is. I have to think. I think that's a Detroit Superior Bridge. Isn't that crazy? I live in Cleveland. I don't even know what the heck the bridges are. You stumped me.
they have a Hope Memorial Bridge,
Yeah.
which looks
They
like the
call them
bridge.
different things. Yeah. Call them different
Oh,
things.
it's formerly the Lorraine Carnegie Bridge.
There we go. See? All right. Thank you. I learned something new today. All right, let me get my slide up here that I had before. Let me find it again. All right, so I have a little bit of work to do here for you. I wanted to just show you this slide here that there is a requirement for testing of gas piping systems. Here's the code section right here, 2417.4. You may want to look at this. You may want to highlight it accordingly. This is the code section that requires you to pressure test the gas piping system. Once it's installed, this is what you do. You actually put a gauge on it through a T. You put a little Schrader valve here. You pump up the system with an inert gas or air or carbon dioxide. You cannot use oxygen, period. Why can't you use oxygen to test gas piping?
Does it expand?
Let me adjust my audio again. I think Carla was weighing in on that. Go ahead, Carla, again.
Does it expand or contract or something?
I have an equation for you late on a Friday afternoon. You ready? Here's my equation. You'll understand this. You ready? All right, here we go. Oxygen plus oil equals boom. Oxygen plus oil equals boom. Oxygen mixed with oil, like cutting oil, causes an explosive reaction. That's why you can't use oxygen. You cut and thread pipe like this, any oil residue, yeah, bad stuff. So the test pressure in residential systems, you're going to find that it's unlikely to go over 3 psi because of the volume of the pipe. In commercial jobs, I mean, you could get over the volume of pipe that may put you over 3 psi, but for residential, 3 psi for a duration of 10 minutes, and that's the pressure test. Guess what? There's another test you got to do. It's called detection of leaks. Look at what this says. Isn't this crazy? Take a look at this. Detection methods include, right, like a combustible gas detector, you wave your wand over the joints and things like that, or a non-corrosive leak detection fluid. How about that, right? We used to say soap bubbles back in the old days. Mix up some Dawn, and soap bubbles and stuff like that. All right, cool. Let me move on here.
Jerry, is that only required if there's a leak and if there's a drop in the gauge?
No.
Okay.
No. Sometimes your pressure, when you have this gauge on here, Doug, sometimes, you will not see a pressure drop or very small increment, depending on how far away the increments are on your gauge, right? So you may not notice a very slight pressure drop, Doug. What you're ultimately trying to do is you're going to wipe all the joints, or you're going to take your combustible gas detection sniffer, and you're going to actually locate each joint and verify that there are no small leaks coming out of the joints. So yes, you are to do the leak detection as well as the pressure test. It's two parts, not just one part. Does that help? All right. Sounds good. All right, here's what I want to do. My method to my madness today is I got to get through ducts really quick, and then I want to show you some venting stuff, okay? So we're going to go through duct stuff pretty quick, duct materials. Here's a checklist for gas piping. Good checklist, a lot of code sections here, a lot of inspection techniques for gas piping. All right, so if we look at chapter 16, this is where your duct materials are going to come from and the installation for ducts. Take a look at this here. In an air distribution system, I guess what I like about the mechanical code is it gives you materials, it gives you all the requirements, but it really doesn't give you a way to design the duct system. It gives you reference standards. It references the ACA Manual J for the heat loss and heat gain calculations, and it references ACA Manual D for duct design, or an approved source, like maybe Carrier or Train has a program that you can design the ducts to. You can even do calculations to design the duct, like what you could even do prescriptive tables like we did the gas piping. So it's kind of lacking a prescriptive way to size duct, but that's okay. You're given reference standards to do that accordingly. Not a big deal. What we're concerned with is, of course, the materials, the locations of the ducts, things of that nature. If I had a house built on a slab, right? Slab on grade construction, the first thing I want to do is find out, gee, what type of ducts can be used underground, right? Pretty simple question. But yet when we go here, I can use underground duct systems constructed of approved concrete, clay, what else? Metal or plastic. Wow, metal ducts, are you kidding me? Really? What about corrosion? But that's addressed right here. You've got to encase metal ducts not less than 2 inches thick concrete around the metal ducts. Or else what we see out there commonly in the field is plastic duct. It's that bluish color. They could be green, whatever, but they are actually labeled for underground use, buried under the slab accordingly. Here's your air distribution system. We won't go into this too crazy, but let me show you how this works. This may be a furnace, it may be an air handler, right? Just like gas piping, look at it the same way. It's no different. It's an air distribution system instead of a gas distribution. Not a big deal. We want to carry a volume of air, ladies and gentlemen, through the plenum. This vertical thing is a supply air plenum. This rectangular thing is a supply trunk, if you will, or a supply main. These are branches off of the supply main. We are distributing air into the room by throwing the air out of a diffuser. The amount of cubic feet per minute is calculated based on the heat loss or the heat gain of the room, okay? That's all based on design. So we're looking for the materials, we're looking for good connections, support, and we're also looking at the return side. The return side is designed to provide an equal amount of return back to the source, which is the air handler or the furnace. If you didn't have a return source going back to your furnace, you wouldn't have any airflow. You would have no airflow, no circulation. So think about this as a whole system, right? Supply, return, just like a boiler, right? Supply piping, return piping, right? Kind of like equilibrium. I want flow going out. I want somewhat maybe equal the flow coming back into my return system to then heat the air up or cool the air down and start the process all over. All right, now I have some code sections here for you. While we're talking about ducts, we're going to say that I've got an electric clothes dryer. Remember this from this morning? An electric clothes dryer. You're going to go to chapter 15. there's a section for closed dryer exhaust systems right here. In general, you're going to be given a specified length. If you do not know the manufacturer of the clothes dryer being installed, you are limited to 35 feet of dryer exhaust duct. Now, the dryer exhaust duct starts from the termination right here, includes the 90 here, all the pipe back to the dryer. Depending on what type of 90-degree fittings and 45-degree fittings you use, you will be hit with a big drop in pressure. If these are short radius 90s, you will calculate 5 feet of pipe for short radius mitered 90-degree fittings. There's a table in chapter 15 that'll show you those fittings. But anyway, if you know the dryer's manufacturers, whose manufacturer is being installed in the residence, then you can go off of the installation instructions, because in the installation instructions, they will list the amount of fittings that you can use and the total length of the dryer exhaust duct to be used. In a lot of cases, you'll find that it's anywhere between 50, 60, 70. I've even seen 80 feet in length that you can run dryer exhaust duct. Okay. Oh, let's see. I want to go over this quickly. Duct materials. Well, that doesn't look like a house, does it? I thought this was a residential class. Same thing, right? A duct is a duct. A duct carries air. A duct distributes air. Well, in residential, we have rectangular ducts that you could snap together like this here. We have round ducts. This one here is called a spiral duct. Normally we see these in exposed basements and things of that nature. What you do have in chapter 16 is this particular table here. Look at this table here. Your system pressure in an HVAC ducted system is based on the pressure, the static pressure in your system. 1/2-inch water column, 1-inch water column, depending on how strong your fan is. You pressurize the duct system. Basically, this table is giving you the thickness of materials based upon galvanized and aluminum and the static pressure of your system. Take a good look at this table here. Okay, this is for round duct. The top table is for round duct. The bottom of the table is for rectangular dimension. And the rectangular dimension is the largest dimension you will use to enter the rectangular table. So let's say I've got a 16-inch round duct. A 16-inch round duct, here I am right here between these two values. And I've got a 1-inch water column static pressure. And I want to find out how thick I can have at a minimum for my galvanized 16-inch round duct. 16-inch round duct. So I go all the way over to my 1-inch water column thickness, galvanized steel, drop it down, intersect it with 15 to 16. Here I am right here, 19/100ths of an inch thick. So you say to yourself, gee, Jerry, what's 19/100ths of an inch? I don't know, maybe like 26 gauge, 24 gauge, probably 24 gauge, I guess. You'd have to get one of them conversion charts, right? But this is the minimum thickness in inches for that particular duct. Keep an eye on that table. Hey, here we go, right here. I've got a little table right here, handy dandy table. Well, let's find it. Where did I pick it? 0.019. 0.019, I don't know. 0.017, well, 25 is kind of an off thing, so probably a 24 gauge right here. See that? 24 gauge would probably be the gauge based on that value. These charts are pretty handy. So they actually convert inches to sheet steel gauge. Okay? Any questions? This is not in your code book. This is something that I kind of downloaded somewhere. Pretty good thing. Okay, beautiful. Little example there for you. Hey, look at that thing. Have you ever seen this before? Maybe you have, right? Here's my furnace. I've got to supply air. I've got to return air. This is all sheet metal coming back. I transitioned around, but as you know, we are allowed to use plastic duct, flexible connectors. Kind of looks like this. This is proprietary. You install this according to the manufacturer's instructions. It's insulated. It's utilized pretty well in unconditioned areas. Section 1601.41 tells us, hey, you know what? If you've got metal duct, you need to construct it according to this standard. See this standard right here? It's called the SMACNA HVAC duct construction standard for metal duct. We actually have the standard to kind of tell us how to put the duct together. If you don't have this standard, pick it up. It's really good. And it's referenced in our residential code. Tells you how to put the ducts together using slip joints, whether they're hemmed or unhemmed. Slips, drives, kind of like this here. Your slips go on the top here. Your drives get beat on the sides like this. See, this is a drive. You actually squeeze the ducts together by hammering the drives on the sides accordingly. Isn't this beautiful? Look at that. As a building inspector, you must admire this, because they didn't drill through this big, what is this, a PSL or something, or a Paralam? Oh my gosh. They did a great job. Isn't it? This is like artwork, isn't it? I'm sure they accommodated for the pressure drop, right? I would hope so. Yeah. So anyway, let me make sure I'm still on. I hope you could still hear me.
Well,
Again, all right, cool, great, excellent. So what's your job as an inspector when you look at this stuff? I don't know, maybe I'm looking at the approved construction documents. Maybe I'm looking at the SMACNA standard. I'm looking for good support, the right thickness of material when it comes to joints and seams, things of that nature. Round duct right here, right? You can see this, ladies and gentlemen, although that the ducts have to be sealed, right? They have to be sealed according to the energy code and the mechanical code, whether you know it or not. Take a look at this. This is called crimp joints here. This is where we crimp the end of round duct, if you will, and we fit it into another piece of duct. How many screws do we need? 1, 2, 3 screws spaced equally around the duct. If you can get 3 around there equally, here it is right here. 3 sheet metal screws or rivets equally spaced around the joint. Wouldn't that be a great test question? I think so. Hard to find? Not really. It's in joints, seams, and connections. Supports, I'm going to go through this quickly here. Support right here, metal ducts need to be supported by 1/2 inch wide 18 gauge metal straps. Non-metallic ducts, you defer to the manufacturer's installation instructions accordingly. So you examine that out on the job site. Here's your flexible ducts, just an application to show you here. Again, these need to be supported in accordance with the manufacturer's installation instructions. It's pretty simple. We're actually looking at the air distribution system accordingly. Question. I don't think we need any question and answers here. Any questions on ductwork? I know I went through that pretty quick. It's pretty simple. Chapter 16, not a lot to know. All right, perfect. Just where I want to be. Venting of mechanical appliances. Last part here. I want you to look at this. I'm in section 503. Okay, so we jumped into chapter 24. Chapter 24 for gas appliances. Chapter 24 right here, 2427, actually is the same as section 503 in the commercial gas code. It tells us, hey, when we have 2 or more appliances, right, that vent into, connect to a single vent, right, the smaller connector needs to enter at the top, right? Larger connector needs to enter at the bottom. Think about this, the volume of flow, right, flowing up this way, right? I want this to be graduated or converged, if you will, into the flow, which is very easy. If this was located on the bottom, you know, it'll probably work, but this works a lot better as far as flow, things of that nature. Fastener penetration right here. Screws, rivets, and other fasteners, of course, shall not penetrate the inner wall of double wall gas vents. You know what they're talking about here? They're talking about B vent. You never put screws in B vent, ladies and gentlemen, because it's proprietary. It snaps together. Except if I have a flue collar, like right here at the flue collar, you are allowed to put screws to fasten the flue collar to the B vent at the appliance. That's the only location permitted for screws. Okay? Do you recognize this, ladies and gentlemen, from early this morning? I hope you do, because I don't have to explain it anymore. We know what a Category 1 appliance is, and we know what a Category 4 appliance is. So with respect to that, I want to kind of do an example here. We want to show you a simple little example of a venting exercise. Bear with me a minute here. But before we do that, I got to go over something with you. Connectors. All right? Connectors. This is the pipe that connects the appliance to the vent or the chimney. You'll look to this table right here for the minimum thickness of connectors right here. So the diameter of the connector, it'll give me the thickness of connectors, okay? This is when we use single wall connectors, okay? Now, if we wanted to kind of look at this thing, we want to try to see if we can do something with the venting tables. The first thing that we need to ask ourselves is, are these Category 1 appliances? The answer to the question is pretty evident here. The answer is yes, because I've got a draft hood water heater. I've got a furnace here that actually connects into the chimney. They're both connected. They're both high heat appliances with high flue temperatures. These are Category 1 non-condensing appliances. So when we look at the venting tables, you need to follow this precisely. Elbows in connectors. This is a connector. Does the code allow elbows in connectors? The answer is yes. How many? Well, they give you an allowance for 2 90-degree elbows. Fantastic. I can kind of come up, maybe go over, and boom, I'm in. You want to get these appliances on the shortest distance possible to the vent. The vent or the chimney is the vertical thing. Remember, connector is the pseudo horizontal thing here. All right? First things first. I want you to look at this. I want you to look at this diagram here. I know it looks like a bunch of scribble, but it's really not. I have a single wall metal pipe being used as a connector to connect my furnace with some kind of a flue collar, right? No fan assisted here, just a flue collar. It's got a little draft hood here, a little draft indication here that it actually connects into this chimney. It's a masonry chimney with a clay flue liner, okay? I have a water heater that takes a 4-inch connector and connects it right into the clay flue liner in a masonry chimney. What we see here is what we call connector rise for multiple appliances. The rise is measured at the connection of the collar or the draft hood outlet of the appliance. It goes up to the point that it connects to the vent. All right. This is a 1 foot rise. This is a 2 foot rise. Look at the capacity of my furnace, ladies and gentlemen. My input rating is 100,000 BTUs per hour. I've got a 50,000 BTU per hour water heater. Now, we call this the least total height. See that word least? We're going to qualify that in a minute here. This is 17 foot. We measure it from the highest appliance. This is the lower appliance. This is the highest appliance with respect to the connector. We take it from the highest appliance. We go all the way up to the top of the vent, not the termination cap, the top of the vent or the chimney. That is 17 feet. Okay? Materials are single wall metal pipe, clay liner, and a chimney. We figured that, okay, it's 38 square inches minimum. How do I figure this out? How do I figure out the connector sizes? Well, the key to this is you locate a table in your code book. This is the table that matches the application, right? It's a masonry chimney over here. You can see that up at the top. We have more than one appliance up at the top right. We have category 1 appliances as indicated. They're not condensing, they're category 1. And the vent connectors are made of single wall galvanized steel. So far, so good. Look at what we have. We have 2 tables. We use the top table to size the connectors. We use the bottom table to size the clay liner. We figure the area out. Now, I wanted to show you something. Wait a minute. I think there's a mistake here. Let me look at this. I don't know. Help me out. What do you think? I mean, I'm looking at the vent height here. It says 15. Let me go back. Let me go back.
The 17, the other.
Wait a minute. It says 17. 17. Is something wrong here? What do you think? 17. Least total height. All right, so let's look at this. Why did we pick 15? Shouldn't I go up to 20? Isn't that how we do it in the tables? We round up?
Is 15 more restrictive in this case?
You never, ever, 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 Jerry sounded like a broken record again. You never, ever, ever round up in the venting tables, no matter what. There's 2 ways to do it. You can interpolate, find a value between 2 known points, like I know 15 and 20, I can interpolate and then interpolate all the values within the body of the table, or you take the next value down. If we round it up, ladies and gentlemen, we increased our capacity incorrectly in the connectors. Look at the values here. These values are in thousands of BTUs per hour. You see what we're doing? If you decided to round up from 15 to 20, right? I mean, kind of look what happens here. Look at some of the values here. If I kind of go into like a 3-foot connector rise with a 5-inch fan assisted appliance, it's 185 here, where it's 199 here in the 20-foot high column. You see, the higher you go, the higher the capacity is. So you either round down or interpolate. So for our application, we're going to round down accordingly and go to 15. So the first thing we're going to do is we're going to check the size of that water heater connector. Here's how we do it. Let me go back. The size of this water heater, that's a 4-inch single wall metal connector, right? I've got a 2-foot connector rise at 50,000 BTUs per hour. Is this naturally vented or is this got a fan on it? Is this naturally vented or does this have a fan on top of it?
It's natural.
I don't see a fan.
Natural.
It's natural. Naturally, it's natural. It's gravity. We call it naturally vented. So I'm looking for 50,000 BTUs with a 2-foot connector rise. All right, here we go. Let's play the game. Never leaving the 15-foot high column. Go to the 2-foot connector rise. For each and every diameter across the top, you have a natural column. You see this? Natural column. Will a 3-inch work? 2-foot connector rise, it only gives me 30,000 BTUs. Is that good enough?
No.
How about a 4-inch? 4-inch natural coming down, 54,000 BTUs per hour.
That works.
That works. That's a 4-inch connector, right? Going back to our application, 4-inch connector works just fine. Whoever designed that did a great job. How about this one? This is also a naturally vented appliance. It says 6 inches. I've got 100,000 BTUs per hour, 1 foot connector rise. Let's go to the table, top table, and size that particular connector. Okay, back to the table, never leaving the 15-foot row. We go with a 1 foot connector rise. I'm going to go to a 3-inch. Will a 3-inch work at a 1 foot connector rise? I'm looking for 100,000 BTU per hour rating. Will 3-inch work?
No.
Nope.
No.
That's 23. How about a 4-inch? That's
Mm,
43. Nope, not really. How about a 5-inch? Nope, that only gives me 73. How about a 6-inch? There it is right there. 112. I need 100,000. That's perfect. I'll size that at a 6-inch connector, 6-inch. So given that, are we done now? Are we done now?
No.
Nope. We have to verify that we have enough area in this chimney liner right here. This chimney liner right here, we have to have enough area to accommodate 100,000 BTU per hour furnace and a 50,000 BTU per hour water heater. Let's add them up. 100 plus 50 gives me 150,000, right? We'll use the bottom table now to determine the area of, not that table, this table. We'll use the bottom table, never leaving the 15-foot high row. We will now look at the labels or the acronyms or the initials here. It says fan plus fan, fan plus natural, or natural plus natural. Which column are we going to be in? Natural plus natural, right?
Right.
Right. So I'm going to go all the way over till I find something that agrees with 150. Look at that, right smack on the money right there. I take that natural to natural, and basically I now have my minimum area of my masonry chimney flue in square inches. And that's how you actually go through and design or verify the design of the liner indicated here. So as we stated, we'll put this down on the drawing so all the building departments know how we're going to install this stuff. And we'll say, hey, it meets code. Any questions on this?
Yeah, Jerry.
Yeah, Don.
We have a lot of unlined chimneys here, and they're putting in stainless steel for liners. So you would presumably be sizing the stainless steel diameter, they're round, the same way, right?
You would use a manufacturer's chart, Don, in the same fashion that we just went through. They have charts that you actually use to size the stainless steel chimney liners and the corrugated aluminum chimney liners the same way.
Oh, yeah, it's not you don't use this code methodology. You go to
Not for those chimney liners, no.
Oh, okay.
And there's there's an NFPA reference. It's NFPA 211 is for chimney liners. You want to write that down.
Yeah.
If you go in the back of your code book in references, I think it's chapter 44, look at NFPA 211. That'll give you chimney liner requirements.
Okay.
All right. Good question.
Yeah, perfect.
Yeah. Excellent. All right. Want to do another example, I think. Right? I don't know. Maybe. I think I have another one here. That's the one we already did. Oh, how about this one? I showed you a table before. Remember that table I showed you that was a cool table in your workbook? I said, this is a table to measure the connector clearance to combustibles. Remember? If I use single wall metal pipe like this here, as an inspector, I need to make sure that you do not have less than 6 inches to combustible materials, right? And here's your tables right here. There's actually 2 of them. Right here in chapter 18, this is for oil burning appliances, and this is your table right here in chapter 24 for gas appliances, 2426.7.7. So it's good stuff, good mechanical tools to put in the toolbox. All right. All right, let's take a look at this table. I found a really nice table. I always find nice tables in the code. Well, I think they're nice because it helps me out. I don't have to stagger around and sift through the code and try to find answers. This is a cool table here. Look at this. If I have a listed category 1 appliance, like a furnace, right? Or a water heater with a draft hood, typical kind of things that we find. Look at this. It gives me the type of venting system. If I have type B gas vent, I'll go right to that code section. If I have a chimney, if I have single wall metal pipe, hey, look at this. Hey, Don, I got one for you. Listed chimney line system for gas venting. Here it is right here.
Yeah.
2427.5.2. You'll find that somewhere in there, Don, a reference.
You said 2427.6.
0.5.2. I don't know. Did you find it in 0.6?
Well, I don't know. That's what my book's saying.
Okay. All right. Not a big deal, but we're
Yeah.
close anyway.
Yep.
So,
Yep. Got it.
all right. So take a look at category 4 appliances. This is where we have condensing furnaces, right? Category 4, these 90 plus furnaces and boilers. Right here, you got 2 code sections, and it's indicated for the venting system, manufacturer's installation instructions for these listed appliances. There's your 2 code sections, 2427.4.1 and 4.2. All right. Rather than bore you with a whole bunch of things here, let's take a look at this. Well, let's see here. Where's my example? Here it is, right here. Here's an example. Our last example for the day. Here's our last example for the day. I wanted to show you this because this is a little different here, okay? This application that I'm going to show you now is for a single appliance. It's a category 1 appliance, right? It's a water heater. It's got a draft hood on it. And basically, I want to use a single wall metal pipe that I can buy from the Home Depot or Lowe's or one of them other Menards or whatever you got. And I want to run that single wall metal pipe into a B vent. You see this connection here? I'm running single wall into B vent, type B vent pipe. From this point, I'm going to go vertical with my B vent all the way up through the roof and put a termination cap on, right? So I have a lateral distance measured from the center of my connector to the center of my vent of 10 feet. The capacity of my water heater is 40,000 BTUs per hour with the draft hood, all right? There's my venting material, B vent, and my connector, or lateral in this case, is single wall metal pipe. Kind of looks like this. I'm going to show you how to do this. We'll size everything, the lateral and the B vent, all in one fair swoop. Look at the height. I measure the height from the top of the draft hood all the way up to the top of the pipe. It's 20 feet. The key to this is trying to find the right table, just like everything. It's a gas appliance. I'm going to go to this table. It's table G2428.2 parenthesis 2 right here. It's a single appliance. As you can see in the upper right-hand side, single appliance, it's a category 1 appliance. And the vent connection, the appliance vent connection, I've got a single wall metal connector. It fits the application perfectly, doesn't it? So I come down here, I go to the height, which was 20 foot. My lateral length, that horizontal length, was 10 feet. I move over to the natural column, the first natural column, and that value is 41,000 BTUs per hour. What was the capacity of my water heater? You remember? It was 40,000.
Oh, 40, yeah, 40.
So I would suspect, ladies and gentlemen, that that works just fine, which it does. And I go all the way up to the top and I say to myself, that's a 3-inch pipe. I've done that in one table and indicated that this whole piping system is 3-inch single wall metal pipe to 3-inch B vent all the way up. And I've sized the whole system using one table and one approach. Okay.
A question on a
Yeah.
3-inch exhaust on the hot water heater.
Yep.
So well, you're theoretically oversized on your venting. Does it matter?
If there's a 3-inch draft hood, Don, on the
Yes.
water heater,
Correct.
I've adequately sized this pipe here for 3-inch.
Right.
According to the table, I've got 3-inch B vent all the way out. It would accommodate the volume of the gas as well.
Oh, you were at 3-inch. Yeah, I'm sorry.
3-inch.
Yep. I'm with you.
Yeah, 3-inch.
Yeah, perfect. We're
Right.
getting a lot of this 3-inch stuff on the hot water tanks that they're selling.
Yeah, and it works fine. I mean, just
Yeah.
looking at the table for a category 1 appliance, we just
Yep.
made it. You see how it just made it here?
Yep, I see it.
41,000 BTUs
Yep.
per hour. Yeah.
Got it.
But here's what happens here. Sometimes the water heaters, Don, will come with a 4-inch draft hood,
Right.
right? So you can't use 3-inch. You got to use 4-inch. You can't reduce it from the manufacturer. You got to use the 4-inch.
Right.
And what would the 4-inch give us? I don't know. The maximum capacity of a 4-inch will give us about 86,000
Yeah.
BTUs per hour. It'll still work,
Yep.
right?
Gotcha.
Good question. Let's talk about some terminations here. Let's see. What do I want to talk about here? Checking the terminations. Hey, we already saw that, didn't we? That table right there, that figure. Again, we're still talking about gas venting, so it's fitting to bring this up. Here's your section 2427 6.4, and it tells us that we could use this particular figure for pipe sizes that are 12 inches or less in diameter. But remember, inspectors, I don't know about you, but every time I pull up to a job, I'm always looking prior to getting out of the car. I'm looking at the roof, I'm looking at the penetrations of the roof, and I'm looking for any kind of walls within 8 foot of that termination of that vent. Remember, cannot be closer than 8 foot to any roof or wall for that vent. Last one right here is the direct vent installation, step 6. If we take a look at this for category 4 appliances specifically, there's some new information here, and I'll tell you how this came about, ladies and gentlemen. You have seen this, I'm sure, where we take category 4 appliances. These are our 90+ furnaces and our high efficiency boilers, and we actually take in the combustion air from a pipe, right? We exhaust the products of combustion from a plastic pipe. The idea here is the manufacturer must specify the type of material utilized for venting and supplying combustion air to that appliance. Now, take a look at this here. It says where plastic piping is used to vent an appliance, the appliance shall be listed for use with such venting materials. You know where that came from? Think about this. PVC piping. PVC piping is primarily used for what?
Water.
Not venting purposes.
Yeah.
What do we use PVC piping for?
Water.
Plumbing. Plumbing, right? DWV, right? Things of that nature. The manufacturers have come to the forefront and they said, hey, hey, all you mechanical people, hey, all you manufacturers, our pipe has never, ever been listed or tested for venting of category 4 appliances. That was the rub for a long time, right? Now they're putting it on the manufacturers that when they build a furnace, a high efficiency furnace, they can have their furnaces tested for use with PVC pipe or other types of plastic pipe, but they have to tell you in the manufacturer's installation instructions what type of pipe to use for your venting and combustion air. That's where this came from. This was a change in 2015, and they actually modified it due to the bar here in 2018. They modified it because there's a new material standard out there. See this UL 1738? Ladies and gentlemen, you are going to see this more and more in the near future. If you ever get a chance, Google this standard here. This standard is not only for category 4 appliances, it lends itself to also stainless steel venting systems for category 3 appliances. It tells us that, hey, I've got a plastic pipe venting material that's labeled in accordance with the product standards based upon the appliance manufacturer. I could use a certain plastic piping, or this is the catch here, or the piping that you use shall be listed in accordance with this UL test standard. If you go out there, you'll see some of this pipe. It's like a dark color with an orange stripe on it. One manufacturer has now produced it for the past several years, and I got to tell you, it's really nice stuff. You could use it with category 4 appliances. So that's how this whole thing came full circle. I like category 4 appliances because, you know what? The fuel gas part of the code is kind of silent on it for the most part. You're to comply with the manufacturer's installation instructions, the number of fittings, the pipe size, the hangers, things of that nature. Oh, my. And we are at the end, finally. Right here. We have a whole slew of inspection checklists for you. Well, I have to say, I hope you enjoyed the Residential Inspection Institute. I mean, I feel for you. You had to sit in front of the computer for 5 days in a row, I guess. But did you learn anything? Did you pick up any cool stuff to utilize? Did you?
Yeah, very
Definitely.
much so.
All right. Fantastic. Excellent. So you had John Gibson for the first couple of days. You had the electrical guy, and then you had to put up with me for the past couple of days, but that's okay. You come well-rounded now. Building, right? Electrical, plumbing, and mechanical. Take these books, take these codes, take these workbooks, use them, study them. If you're planning on taking ICC examinations, these are all good tools. Furthermore, you can get study guides, right? Questions that can be purchased to help you become more fluent on finding code sections and understanding them. Any questions or comments before I turn it over to Selena, if she wants to talk? Questions, comments?
Jerry, what ICC tests or certifications does this Residential Inspectors Institute help prepare you for?
Well, you could look at the B1. B1 is the residential building inspector. The E1 is the electrical residential inspector. The P1 is the residential plumbing inspector. And the M1 is the residential mechanical inspector. Okay?
Okay.
All right. Well, I hope you enjoyed the course, ladies and gentlemen.
Jerry,
Yeah.
Jerry? Oh, go ahead.
I have one question, Jerry.
Yeah.
Before G2407.11, there was an exception about, venting with combustion air, the furnaces, and wall cavities or studs. Is that permitted?
For combustion air. Yeah,
if
hang
you-
on a minute, Francisco. I'll go to that code section for you real quick. I know what you're talking about. Let me bring my code book in.
What I'm getting at is, I know at one point it was an article saying that was prohibited in stout cavity walls.
No, it's not prohibited. It was allowed, I believe.
Yeah,
And doesn't that interfere? How are you going to deal with the fire blocking though?
Well, you're allowed to do that if you don't remove more than one fire block.
right.
That was the kind of driving sense of this thing.
It-
Hang on, let me find that real quick for
I mean,
you.
you could still have another code that overrides that, right? Like something in the energy code or a local or a state requirement. That,
You know what? I've heard that over and over and over again where the energy code overrides. Make no mistake, ladies and gentlemen, the energy code does not override the mechanical code.
Right.
If you are to bring in combustion air for a mechanical system, sure, there's maybe more than one way to do it. But if that's the only way that you can do it is go into like a cavity wall, don't make it an exterior wall for sure. Because, you know, at that point, now you're into insulation, things of that nature. But when it comes to the safe operation of mechanical appliances, believe me, the energy code does not override any kind of safety features and functional operation of mechanical appliances. Okay? Bear with me here. I got to get to Francisco's question here. All right, Francisco, I got this code book up on the screen here. I'm going to go to 2407
11.
Yeah, right on. I'm going to get it somewhere around here and scroll down till I find it. Hey, here we go. There it is. All right, so we have a bunch of items here, right? Duct shall terminate, serve upper and lower, screened, horizontal, blah, 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 blah. Let's see. Let's see if we can find it here. Combustion air openings, solid fuel. Da, 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 da. I can't remember. What are we looking for here?
If it's permitted or
cavity.
prohibited.
Duct shall, okay, duct shall terminate in an unobstructed space. That's fine, right? Serve a single enclosure, right? We're looking for something that just may be understood. Upper and lower. Upper, lower, that's fine. Screened. Yeah, I'm not seeing anything. I think what that came from was the code commentary, Francisco.
well, it's
Where-
the exception, is that it or no?
Oh, I don't know. Let me check here real
Under
quick.
one exception on that same page?
Oh, let me check here. I don't see any exceptions here. I see items right here.
No, yeah, it's what you were just on right
Oh,
there,
right
number
here.
one
I'm
exception.
sorry. Yep.
Yep.
This one right here. Yep. Unobstruct. This is it right here. Yep. There's our fire block. So the unobstructed stud and joist spaces shall not be prohibited. Yep. That's it. That's exactly what we found.
Just a comment on that, Jerry, that the energy code calculations, we should have to check, allow a certain amount of area, particularly with windows, but it could be used for this, of non-complying area. And you would have to be within that allowance. And we sometimes have that happen here in remodeling, and they'll put it on an exterior wall and they'll want to use the trade-off for the whole cavity. You go to the energy calculations, and if it's underneath that allowance, you're good to go. You can do it. If not, you know, then the energy code it doesn't. You can't violate the energy code in the mechanical code. But what Jerry was saying is, as far as the energy code doesn't override the mechanical code, that I don't see that as an overriding factor.
Yeah. So you got to try to come up with the best solution based on both codes. And yeah,
Yeah.
we
Yeah,
come
here's
up with good applications.
For residential, here is 12% of your in your energy calculations. But
What is that?
That's right. And that's
Well,
right.
Yeah, you're getting into the AHJ stuff.
I know.
Yeah.
And then the building official weighs in, or the code
Right.
official. Yeah.
Yeah,
But Chris, you're right. We don't want to hamper the safety or the operation of a bona fide mechanical system. That comes first and foremost.
yeah.
Energy comes secondary. And that's the intent of the mechanical code. So there's got to be a happy medium. I had gotten not a scuffle, but there was an energy rater that came out to a home and just got all over the builder. Said all of a sudden, you penetrated the exterior wall with a louver to bring in outside air into your mechanical room. How dare you do that? You blew our blower door test by doing that. You need to cover that up immediately. You need to block that in, is what the energy rater said. Guess who called me? The building contractor called me. We approved the drawings. We approved the outside air with the louver in it that way. I had a meeting with the energy rater, and I had to bring in my mechanical code and my energy code. And I bantered with him a while, and I said, number one, this is a safety issue. We will not block the combustion air in the building envelope to the exterior. That will stay there. That will remain there. That's a function of the mechanical.
His connection went.
Jerry, you're going out.
Okay. Can you hear me okay?
Yeah,
Testing. Testing.
you're good.
All right, beautiful. All right, any other questions? Great questions. Good class. Great class today.
I do have a question. This is probably old, but I was wondering, have you heard about the up ducts for like a master cool, and how does that affect combustible air, and is there provisions for that in the code as well?
What was that, Carl? Can you say that again? A little louder?
Up ducts, like if you have a master cooler on a house, a swamp cooler basically, and
Oh, yeah.
you have
Yeah.
combustible air, and there's up ducts in the house with, they're pressurized when the swamp cooler kicks on, so I have to leave windows open. It relieves the air, and with combustible air in certain areas, how does that affect? Is there a code in the IRC for that? Is there a table or anything?
Well, a swamp cooler, if I understand right, is where you actually take water over a panel and you circulate it by means of a fan, right? For cooling purposes, for evaporation. Is that what you're
That is
talking
correct,
about? Combustion
Yeah, but
air.
you gotta have.
Combustion air, I don't think plays a part in that, due to the fact that we're not bringing in combustion for fuel gas or oil. That's just strictly like an air circulation method to cool air down, correct?
That would,
Correct, but it applies a positive pressure to the room, is what I'm saying. And it's relieved through an up duct in the ceiling, because you open a window and so how does that affect, and is it a combustible air like for a water heater and things like that? Does that apply in the code as well?
Yeah, it's called depletion of combustion air. It's called makeup air. Makeup air. That's that house that I showed you, remember? It's called depletion of combustion air. We call it makeup air. You have to bring in enough makeup air for any type of exhaust or exfiltration, and it's called makeup air. So go in the index of the code book and you look up makeup air, you will find your answer in that code section. That's exactly what you're talking about. Good question. I understand now. Great.
Because it can
Bring
affect
everybody into the screen here.
air.
Oh, I can see
On a
now.
positive pressure.
Okay. Any other questions? Questions, comments? We good?
Hey, Jerry, before you close out, I just wanted to mention to the class that your certificate of completion is available in your Learning Center account for this week. So if you want to follow the instructions that are in the chat, log on to your Learning Center account, click on your training and your transcripts, and then you can print and download from there. Don't go to your My ICC dashboard. You're not going to find your certificate there. It's only in the Learning Center under your completed courses through your transcript.
Okay, thank you, Selena. Do we get like a coupon for dinner or something for the ICC for all the participants?
I was
that have
hoping
put
that
up
you
with
guys
this?
would all chip in. I
Hey
mean, I've
now.
been working like a crazy cat all week long trying to go on vacation next week and close up. So
Vacation? Yeah.
What's that?
Selena, you did a good job. Fantastic.
yeah, a
You
forced
gotta-
vacation, or I use it or lose it.
Uh-oh.
That's what it
All
is.
Yeah. Cool.
Okay, so if you have any questions, you can always email the Learning Center. But again, look at the Learning Center website, log in, same username and password as you were to use on your My ICC, you know, and you can all get your certificate from there. And any of you, I heard and I was listening in here and there, and I know a lot of you are asking questions regarding the B1 exam. This training is actually on the career path, but we do have a certification test academy where it's basically a skill and drill of that B1 test. So if that's something that you're interested in, we do have a couple of options for you to attend here coming soon on the Learning Center. And I think the dates are, and I can give you them in just a second. I look them up.
I think we have a mechanical test academy for the M1 coming up.
Yeah, we probably have the mechanical too, but specific to the B1 on that residential track, it's May 3rd and October 4th. It's, you know, bring your code book with you, you know, you go over the outlines and you skill and drill so that you can be successful in passing that B1 exam. And the cost of that does include the B1 exam as well. And Jerry, are you teaching the M1 Academy?
Yeah, I'm teaching the M1 and the E1, I believe.
Okay, and those are you that are interested in the M1, that is July 13th through 15th. So everything that we have and that I'm talking about is on our Learning Center calendar. You know, you can click on the date and you can get the description, pricing, and everything like that. But thank you all for attending. I know that it's a long week. I know that this is not something that everyone's used to. We would all love to be in Austin, Texas, as we usually do this time of year. But, you know, thank you for your patience, and I hope you enjoyed the class.
Thank you, Selena, for everything.
Good.
Gary, great training. Thanks a lot for everything.
Thank you, Francisco. Have a good weekend.
You too. Take care.
Thanks, Chris.
Thanks, everyone. Good night.
Thank you.
Off to go get COVID vaccination.
Oh.
Woo-hoo.
Thank you, Mr. Planet.
Thanks, Paul. Yeah. Be nice.
All right. Have a great weekend, everybody.
Thanks, Chris.
Bye.